Good morning, 8th grade students. All right, it is time, and you know me, Miss Jackson from Brinkley Middle School, and today we're going to talk about volume. Now, you've learned some volume formulas from your previous grade level, so we're just going to add a couple more formulas to your repertoire. Today we're going to learn the formulas for volume of a cone, a sphere, and a cylinder. So the first formula we're going to talk about is the formula for volume of a cylinder. Now, a cone. The cone looks like what you know a cone to be, an ice cream cone. So it's no misunderstanding. And that's what it is. And the dimensions that you need are height and radius. Height and radius. And then you substitute those values into your formula. So the first thing you do is write your formula. Our formula is V equals 1/3 pi radius squared height. And remember that symbol pi, and we approximate it to be 3.14. It's approximated to be 3.14. It is not equal to 3.14 because all the 8th grade students know that that is an irrational number, and it goes on and on and on and on and never ends. Okay, so 1/3, and we'll use 3.14 as its approximation for pi. Our radius, if you look back at our diagram, our radius is 2 centimeters. So we substitute 2 in for r, and our height is 8 centimeters. So I'll substitute 8 in for my height. And from there, you can use the order of operations or just punch it in your calculator. So I'm going to simplify mine just a little bit because I'm using my cell phone calculator like many of you are probably doing. So we'll do 1/3 times 3.14, and then 2 squared is 4. And now we can punch this in our calculator a little bit easier without having to worry about the exponent. So 1/3, we know we represent it as 1 divided by 3. So 1 divided by 3 equals, and then we say times 3.14 times 4 times 8, and that gives us 33.493. I'm going to round to the nearest hundredths, so I'm going to use this 3. So I'm going to approximate that to be 33.49 centimeters cubed. And whenever you're doing volume, it's cubed. Just like with area, it's always squared. With volume, it's always cubed. Great. So we'll try number 2. It's a cone. So V equals 1/3 pi radius squared height. So 1/3, we know we're going to approximate pi to be 3.14. My radius. Well, when I look at this diagram, I see I don't have a radius. I actually have the diameter. My diameter is 6. So when my diameter is 6, what is my radius? Y'all not finna sit there and tell me y'all teachers didn't tell y'all how to find out what the radius is when you give the diameter. Oh, okay, I thought y'all remember. 6 centimeters is the diameter. That means the radius is actually 3. So we'll substitute 3 into our formula. And then our height is 4. So I'll simplify this just a little bit so I don't have to worry about trying to put the exponent in the calculator. So 3.14. And 3 squared is not 6. 3 squared is actually, 9. And times 4. And we just punch this in our calculator just like we see it. So 1 divided by 3 times 3.14 times 9 times 4. And we get 37.679. I'm going to round to the nearest hundredths place. So that 9 is going to make this approximate to 37.68, and my unit is centimeters cubed. Everybody good on volume of a cone? Great. So we're going to go ahead to sphere. Now, sphere looks like a ball. So your basketball, baseball, those are all spheres. So you've had an interaction with spheres before, you just didn't know what it was called. So we're going to use our formula, which is V equals 4/3 pi radius cubed. So the only dimension we need for this is the radius. Well, if you look at our sphere, the radius is 6. So 4/3, we know for pi, we approximate it to be 3.14. And then we'll have 6 cubed. We're going to simplify this first. So it'll be 4/3, 3.14. And do not say 6 times 3. We know that's not right. It's not 18. If you don't know what 6 times 6 times 6 is, just put it in your calculator. So we do 6 times 6 times 6, and we get 216. And then you just punch it in your calculator as we see it. So 4/3, so we say 4 divided by 3, enter. And then times 3.14 times 216. And we get 904.319. I round into the nearest hundredths. So it approximates to be 904.32 centimeters cubed. Easy? I know it. Number 4. So you look back at this sphere and we don't have the radius anymore, we have the diameter. So if the diameter is 8, the radius is, right, it's 4. So V equals 4/3 pi radius cubed. So 4/3, we substitute 3.14 in for pi, and my radius is 4 cubed. So I'm going to simplify this part of the expression first. So 3.14, and if it's not 4 times 3, the answer is not 12. If you don't know what 4 times 4 times 4 is, punch it in your calculator. So 4 times 4 times 4 equals 64. And then just punch the rest of the expression into your calculator. So again, 4 divided by 3 equals, and then times 3.14 times 64. And we get 267.946. I'm going to round to the nearest hundredths. So we're going to approximate this to be 267.95 centimeters cubed. Got it? So the last one we're going to do is a cylinder. Now a cylinder simply looks like a can of vegetables, a Pringles can, a paint can, those things. So again, you've had some sort of interaction with cylinders before. So just ignore that part. Just ignore that. All right, y'all. Just bear with me. So the dimensions of this is the radius is 2 centimeters and the height is 8 centimeters. So the only dimensions you need for the cylinder is the radius and the height. And we're going to use our formula for this. So our formula is V equals pi radius squared and height. So as always, we approximate pi to be 3.14. Our radius is 2 squared and our height is 8. And so we simplify 3.14. 2 squared we know is 4. And then bring down our times 8. And then just punch that in our calculator. 3.14 times 4 times 8. And we get 0.48 centimeters cubed. And that's the exact amount. There was no rounding necessary to round it to the nearest hundredths. And the last one is that little can there. Okay. So we're going to pause here for time's sake, you all. I'm sorry I ran out of time because I have an assignment for you. I want you to go to the JPS Learn at Home site and find the assignment that says Aquarium at the Jackson Zoo. And your task is, as an engineer, to design an aquarium for the Jackson Zoo. You will construct it using either two-dimensional or three-dimensional shapes, and you will present this information to your families. Just use the hashtag, and if you have any questions, contact me at the information down at the bottom. Thanks, and y'all have a great day.